So today I'll be discussing on 3D concrete printing technology. So in line with the advancement in technology or emerging technology, again, how the role of cementitious material will play a important uh, role in this emerging technology, so called 3D concrete printing technology. So just to well before going with this 3D concrete printing technology, I just would like to give a brief information about our institute. I think you all already here and then online participants or know about our department. So Department of Civil Engineering was established in 2022, and right now the very first batch of the civil and infrastructure engineering are at the stage of graduation. So we are our department is a 4 years old young department in IIT Dharwad, and we have the faculty members in the various specialization, including geotechnical engineering, structural engineering, water resource engineering, and transportation engineering. These are the wide range of faculty members from the department and their key area for research focus. And also we our networking with the industry and academic collaboration as well as the international collaboration. So talk about today's important topic, the reason for looking at the emerging technology, why do we need emerging technology, and what is the essentials to introduce or overcome of the traditional construction practices, right? The very reason for looking at some of the emerging technology is the demand for infrastructure. So when you look at the demand for the infrastructure, if you look at the infrastructure sector, the growth of the infrastructure, so what we could see that there is a growth of the infrastructure increment about the 8% every year. CAGR rate is 8% of the requirement or demand for the infrastructure. So where if you look at 2025 and next 5 years, so the demand for infrastructure, the sector is booming, and there is a lot of requirement in terms of the execution or to meeting the demand of the infrastructure growth. So that is where even there is a robust demand. It's looking for the enhancement in infrastructure. It could be anything of such improvement or the growth, economic growth of the nations is always dependent on the infrastructure. And if you look at the recent financial budget of the year 2025 and 2026, the 3.1% of the GDP is reserved for the infrastructure. So that is the kind of a demand. And when you look at the infrastructure demand, the important role as a civil engineer or as a structural engineer or any of the engineer for that instance, their role play a vital in terms of the building this infrastructure. So that infrastructure, out of which one kind of the material what you would look at, or in order to meet the demand of the infrastructure, the first and foremost which we talk about next to the water is concrete. And again, when you talk about the concrete, the art of a concrete is a cement. So the demands for the cement is projecting and it is increasing over by the over year over the year, and that compounds for about 7 to 8% of the requirement of the cement in order to meet the demand or in order to build our infrastructure. Although the financial contribution or enhancement whichever is reserved, in order to meet that we need to have the kind of a sources to build it, right? So that is where it is reported by the GM Financial. So there are attractive opportunities. In order to build this, the government is just announced a 3.1% of the GDP to build the infrastructure. So it is not just about the reserving the financial support for building the infrastructure, but on the other side, there are attractive opportunities to build the infrastructure. So where it could boost the transport efficiency, so which is essentials to growth of the any of our tier 1 cities, and also demand for any of the commercial opportunities in tier 2 and tier 3 cities where we are looking for many of the commercial corridors. For instance, if you talk about Pune, Mumbai, Pune, and Bangalore, Pune, and again we talk about Chennai and Bangalore, Hyderabad, Bangalore. There are many corridors which would be connecting or looking for the commercial opportunities and need of this transport efficiency in order to connect business, right? So that is the need of again the infrastructure and policy support. Obviously, as I mentioned about in terms of policy support, the union budget had reserved the fund, and likewise there is a increasing in the investment. If you look at the other investors who would be investing in the infrastructure, so there investment is increasing year over the year. So there are numbers which you could refer it to understand the demand for infrastructure. So there is significant growth in terms of the electricity, in terms of the, again, national highway constructions, in terms of the rail freight, and also it is extended to cargoes. So there is extended uh, importance on increasing the various growth in various sectors and their respective compositions. So which kind of the trend you'd be showing it about road construction per day. So which every day we would be noting, no, I mean, understanding the growth or the trend is going in terms of the construction. So these are a couple of government initiatives also supporting for meeting the infrastructure demand. On contrary side, it is also important to understand the sustainability, right? So if you talking about the sustainable development goals, so which is established in year 2016 from the Paris Summit. So in the Paris Summit, there are 17 sustainable development goals have been defined, and then where most 192 nations are working towards achieving these sustainable development goals. And the important role what is playing achieving the sustainable development goals out of 17 goals. So you can see that industry innovation and infrastructure. So one kind of where we can think about contributing it directly or indirectly. So we can also contribute to the sustainable cities. So we can also act upon based on our kind of implementation or looking at the alternative sources for our any of the demand in, let it be the cement or either it is any of the natural resources, whatever we are using it as a traditional construction materials, so we can overcome of it. And this is again revisited and recited about achieving up the sustainable development goals in G20 was held at South Africa in 2025, which is one of the three pillars as part of this G20 is sustainability. So also we have the other components, but as far as this thematic is concerned, we will be focusing on sustainability. So in this line, our research center would be working on most of the emerging technologies and also would be working on the sustainable innovative materials. So one such kind of the thematic research would like to present it through this today's session is introducing of the current ongoing research and construction waste, and those waste are converting as the innovative materials, and finally adapting the emerging technology of 3D printing and building a 3D printable structures. So similarly, again, it is there from our roots about using of our indigenous materials. Again, introducing of these indigenous materials in 3D printable, 3D printing technology is another kind of the vertical we would be discussing in today's technology or as part of the today's session. So this is about the material. When you look at emerging technology, so I just wanted to start with the introduction. So how this technology is different than the existing technology, so-called the traditional construction techniques, right? Our traditional construction practices. So what are the challenges we have it in current, I mean, traditional construction practices? Anybody can name few? The kind of challenges we have been facing it now. Let's say that our demand is used, right? So the demand is increasing 8% year to over the year, right? That is a compounded growth average rate. So what are the challenges we are facing it? Why are we meeting the required demand? Depleting of natural resources, quality issues. Pardon?
Time consumption for the construction.
Yes. So again, the project time, which is most important attributes towards or meeting the demand. Anything else? Economic feasibility. When we talk about the time, so when you wanted to cut down the short down the time, then it is comes with the additional cost. So whether it is economical feasible or not feasible, so that is also important, and that is where the current challenges in existing practices. Any other points you would like to add on? Material wastage is also adding on because whatever we consider it as a solid waste, right? The solid waste is goes to the landfilling, but again you are not working towards contributing to the sustainable development goal, but we are working on the other side, counter side of or negative side of the contributing to sustainable development goal, which goes to the landfilling, pollute the soil, pollute the water body, and we already facing a lot of challenges to get the pure, even pure air itself, or we are not getting a pure water of drinking. So these are all challenges we have been facing it. But when you look at the technical aspect, technical challenges, what we have been facing with the traditional construction practices, so the first and foremost thing is the labor, right? When you want to achieve the project time on time, so there is a shortage or shortage or the scarcity of the skilled labors. Although you might be having the labors, now there is a huge scarcity of the skilled labors. So always it is dependent on the skilled labors. When you have the labor force, so definitely you could execute, you can complete your project on time. So that is the one such kind of a thing. And as rightly mentioned about the waste generation, so that is also leads to the over costing on the project, right? So likewise, if you look at the overall picture of the traditional construction pra practices, so where it is start from the long construction time, because your activities are depend on many of the things, including the lab, like three things. First one is money, and then man is nothing but the manpower, and then it is also dependent on the machines, right? So these three things should be well in place in order to execute any of the projects on time. And when the demand is high and our supply of these three M's are what we call it is a vitamin, three vitamins of the construction. If it is that lacking, definitely there will be delay in project. And there is a labor shortages, because what we would see it now, there is significant decreases in it is labor availability. That is where we see that most of the laborers now either from the other states or from the other places, and that is also having a skilled labor is more challenging. So shortage of the laborers, and these traditional practices are leads to major labor injuries at the site. So due to very compromises on the safety of the construction, because construction safety is, we are not well adapting or not well practiced in at least in Indian context. So that is where we always know, record kind of or we report that there is a labor injury or in the current existing practices. Again, in the existing practices, there is a demolition waste, and most important thing, our cost, whatever in the current practices is demands for the formwork, right? So at least 60 to 70% of the cost is goes with the formwork. Although material cost will be accompanying by about another 30%. So the use amount of the cost, again, the cost is not just about what you will be doing it as scaffolding. It is comes with the again three M's. What is the machines used, manpower used, and overall things what would be required. So that cost will be going with the formwork wastages. And in terms of the sustainability, it is high environmental impacts. When you look at the whole life cycle of the construction process, so including the waste generation or start from the consumption of the cement. When you look at back the production of the cement, so at the whatever emission of the CO2 is start from even from the day one of manufacturing of cement towards utilization of the cement, and then to there are many other construction materials. So this is a holistic view of the traditional construction methods. Now to overcome of all these challenges, so where we are trying to introduce so-called emerging technology, that is none other than 3D concrete printing technology. So this 3D concrete printing technology, where we talk about the major challenges of the formwork wastages, can be overcome with a 3D concrete printing technology having no formwork. So this emerging technology will address the first and foremost issues, something about the project cost, right? So when it is no formwork, then when you look at the demolition waste, the relatively there is no waste generated in the emerging technology called 3D concrete printing technology, and this also required less manpower, although it is a skilled manpower, but the number when you compare to the traditional construction practices, it is significantly low and less so of use of the manpower, and it is more sustainable way of approaching by introducing something of alternative to the cement, or wherever we would see that there is a depletion of our natural resources, there is a overconsumption of the cement. So here we are trying to introduce a blended cements, a blended or what we talk about cementitious material. So that is the kind of advantages we would be getting it from the 3D concrete printing technology. Again, cost effective. So you would be thinking about just one component as a material. So 3D printing technology is not just about the change of material, although there is a rich cementitious or binder components are used, and that is already well versed with the another kind of a technology what we talk about, ultra high performance concrete, which does not have any aggregates. So we should think in that level of the technologies rather than coming back to look at the brickwork and then brick masonry work. So where the cost is low and the cost is high. But that is the one thing is absolutely true. Like when you look at the material perspective, it is quite expensive. But when you look at the other aspects, benefit what you would be getting it from the formwork. It does not require a formwork. In the place of a formwork, again, there the what kind of a machines you would be using it. There also you are intervening or introducing kind of a machines, but that cost reduction will be significantly more in the case of when you are replacing with a former basis. That is the one advantages what you would be getting it from the 3D printing technologies. And the people around here, if you are again, I hope that you all of you know about a 3D printing technology. So if you're looking at by definition of the 3D printing technology, so this is an innovative construction technology which will be giving design freedom. So one of the other component what I try to address, because most of our typical construction practices are the regular shapes. So anything of you want to have the design freedom in construction, so this is the most efficient and suitable technologies using of the method called 3D printing. So this gives a design freedom, faster construction rate, and there is a less waste, and also it would be the cost effective in overall project cost. So this required high proportion of the cement and fine aggregate than the conventional concrete. So that is where we always stand at the point and think that this is not the cost effective. It's not essentially, it is not just about the conventional concrete. When you look at the other special concretes are available in the market, when you are trying to design and meet the requirements or to meet the demand of the infrastructure, definitely this is more important when you're going with the technology and incorporating of these any of the available or whichever we call it as the recycled construction waste or even any of the alternative industrial byproducts. So by replacing so that you can overcome of the intensive usage of cement and aggregates. And again, type of the printing technology or printers available in the market, so which extensively we can think about suitable for meeting the infrastructure demand in a construction. So we have Gantry type 3D printers, so which is extensively used in any of the large scale 3D concrete printing to print of any kind of the structures. And we have robotic arm 3D printers, so where have would like to have more geometrical freedom. So in such cases, to achieve any kind of the architectural applications, so the robotic arm printer would be helping you out. And now this is where is scarcity of the land in any kind of cities. So you can try to use the printers called truck mounted 3D concrete printers. So this will be allowing you to go to the location and print it, and so that it really don't need the kind of a space in order to print it like the cases of gantry type. We have cable reinforced systems and delta style printers. This is subject to the requirement or kind of applications where you'll be looking for the design freedom, and you would also be expecting for more access of the freedom in while printing up the 3D concrete printing. So this technology is involving of these steps. So the first and foremost, you develop the 3D model. I think we all civil engineers, we know that we have been using of the uh, kind of a modeling. We earlier days, like in decade ago, we just were stick on to the 2D. Now it's very common everywhere. We can see that 3D. Even for a small residential construction to the any of these large scale projects, so we go with the 3D. But now here, in order to make the 3D printable concretes, so again you develop a 3D model using of these various tools or softwares are available in order to build a 3D models. So most basic one and most compatible one with the 3D printing is SolidWorks. So for a concrete 3D printing, we have Rhinoceros 3D and Spiren. So the Fusion 360 is also comes from the Autodesk. So where we have more advantages of generating the generative AI based 3D models. So you just give the rough sketch of the typical model, and where you can take the advantage of generative AI to get more advancement in the model. And further you go on, once you develop this 3D, the next platform what would be required is slicing into the 2D layers. So that is where you have Cura, Spur Slicer, and cruiser slices, or these are the kind of a slicing tools where you can use it for uh, slicing of the developed 3D models by using of these SolidWorks or anything. So most common platform which is now being used or in the practice is, first you will go with SolidWorks here, you use Cura here, and in G code generation you will have Marlin. So that is integrated inbuilt system in the 3D concrete printing, basically where you will be having a controller. In the controller you will be having this G code generation to export a 3D printers. And finally, this system will be extruding the elements based on the kind of a G codes generated by using of these two of the platforms as a softwares. So this is the whole process. But now, what is important as the civil engineers, or when you are trying to talk about as an expert of construction materials, what is your role in this 3D concrete printing technology? Anyway, this should be doing it by machines or the printers, right? What is your role in the 3D printing technologies? Optimizing the mix? Any other answers? Rheology studies. Why do you think rheology is important in these cases? Setting better, extrudability. So that is where you require a rheology. Any other, making it more economical? Any other points to be added? Viscosity, yeah, part of the rheology. User friendly. Okay. So I think our expert had discussed about many of the things, right, while doing the numerical modeling. Anything you could connect from the numerical models to this 3D printing technology, which is a common parameter we need to think about it in 3D printing technology based on your understanding and learning from the last 2 days sessions, right? Was there anything is connecting with 3D printing technology from the international experts? Dr. Nevin is discussed about various factors, right? No, I'm trying to connect from the last two sessions to this. Is anything is relevant to the 3D printing technology? Sorry, exploring different types of the ACMs, hydrations. So we talk about SEM, and then we also talk about hydration. Okay, something about strength parameters, nucleation. Okay, nucleation and growth of these cementitious materials. All right, this we can connect it. SEMs, it's as we have been practicing in many other different types of the concrete, not necessary of the concrete suitable for the 3D printing. So when we are looking into the replacement of ordinary Portland cement, definitely we're looking for something about the SEM. And the background about the SEM start with the hydrations and their behavior. So that is already well discussed in the last 2 days session, right? So apart from that, some of the properties are very important. So those properties, what we were investigating in 3D printing technology are these. So after looking into this, then again we'll come back to the discussion. So are there any property are interlinking with the last two sessions? So when we talk about, so already we prepared a mix, right? So when the mix is prepared, it is about the, so when we talk about in the previous steps involved in 3D printing is extruding elements. So that is a second parameter had mentioned in this slide, that is about the extrudability. So in any typical where you are trying to manually print it, so in such cases, definitely you go for the extrudability. So what is important in extrudability? Ease of flow. Okay. It should be continuous and uniform layer formation because it's layer over layer deformation. So layer over layer formation, right? So there should be ease of flow. So what is the mechanism while you are building ease of flow in your concrete mixture? Admixtures, just those are the chemical, but what is the basis? Where is the fundamental lies with this your mixture? It should be homogeneous. It's all about concrete technology. But now we are going something beyond of the concrete technology. Again, it is lies with the basis of basic science of the basic science of engineering. Bonding. Okay, this is something about, as you mentioned about rheology. So most of the things are connected with a rheology. So what you study in rheology? What is a rheological study? Shear stress, plastic viscosity. Basically, it deals with a flow. And when you are dealing with a flow, it is about a fluid, right? So when you are trying to understand about a fluid, there is either fluid is in the form of liquid. All liquid are fluid. Yes or no? All liquid are fluid, but all fluids are not liquid, right? So that concept is very clear with us. So there could be even presence of gaseous and then the liquid form in of the fluids. So here what we are trying to connect in order to make it relevant mixture for a 3D printing concrete is about the flow of fluid. So how does it flow? Again, it is something deal with the fluid mechanics. So what you have studied in the, I mean, what you have, what all your understanding about the fluid mechanics and which we can connect with the concrete discharge. So have you heard about Newtonian fluids, non-Newtonian fluids? So what is Newtonian, what is non-Newtonian? So rheology is not difficult for us because day-to-day life in every day it is part of our life. Anyway, I'll come to that point in the next slide. But before that, I just wanted to make you understand what all properties are important. It is other than the cementitious material or concrete mixture. It is not just about a concrete technology. So you are connecting with two things. So where in order to achieve by adapting of the emerging technology, it is behind of your concrete technology. Concrete technology is just make sure that you have the ingredients called cement and fine and coarse aggregates, make it of a homogeneous mixtures, and then you make sure that it is achieves the workability, strength, and over the period of its durability. So that is all it's a meeting about the required about a proper concrete property. So there you don't test it on any test bed. But now the year challenges is whatever mix you would be developing it, you testing it on the test bed. So the test bed over there, just you have cubes, so you dump it in the cubes, follow the standard procedures of 3 layers, and every 25 blows even manually you can print it. But that is not the case in 3D printing technology, right? So the 3D printing technology is deals with all of these properties. So just try to remember these properties. Then one over the period when we're discussing about the rheology, so you would be able to connect it. What is what? Right? So just wanted to make you understand. So this is not about concrete technology. It is something behind the concrete technology, but again, it is connected with something about the flow of the fluid. So in a flow of the fluid, you will have different types of flow of fluid. So Newtonian and non-Newtonian fluids, right? So again, once you are able to distinguish about the Newtonian, non-Newtonian fluid, and where you are categorically you put your concrete mix in one specific category, then you are able to further go ahead to meet the requirement of all of these things, right? So you require pumpability. So I think this is very common. You have seen in common construction practices also, where you will be having a boomers or pumping units to pump the concrete. So here also you require a pumping units in order to pump the concrete mixture to the concrete printers. So where the concrete printers through the hopper where it can go to the next property called extrudability. So here this is layer by layer deposition, right? When you have the layer by layer deposition, it should be continuous and there should be uniform layer. This is again when you talk about uniform layer, it is also deals with your rheology, right? So what the rheologists talk about is talk about its texture, it talk about its first of all its flow, then retaining of its shape, then it's about the texture. So that is comes in extrudability. Then another important thing is we had mentioned about shear rate and then shear stress, right? So why do we deal with these two terminologies, shear rate and shear stress? So you all using of your pen, right? Is there any of the rheology involved in your writing in it, right? So when you write it, there is a shear rate you apply on it, right? So what is the mechanism involved in using of the pen? External force applied. So what is the shear stress by definition? Force by area. So what is the kind of force you will apply on that area? And now the shear rate is subjected to the flow of your fluid. So is it works under the condition of high shear rate or the low shear rate? You write it and then you keep scribble it so that you can understand. Is it high shear rate or low shear rate? Right. So I think you just see that what is important while writing. Pressure is fine, but why do you have to apply such pressure on a pen? Not necessarily everyone would apply the pressure, right? So I would apply low pressure, somebody would be applying very high pressure, somebody will hold it very strong hold on the pen and then they write it. What all important finally? What all you are looking for? Small ball should have the proper lubrication to move it, right? So can you connect this to 3D printing technology? Yes. So this fluid is what you are talking about concrete mix, right? So then whatever the ball you have placed it at a nib, right? So that is a mechanism where this flow of the concrete, it should be having proper lubrication. Then you will be having this wall. It's called shear wall. And in some cases, whereas in a Newtonian or non-Newtonian, so then you will be having it is subjected to. I think this is Newtonian or non-Newtonian. The ink what you use it in the pen. Non-Newtonian. So what is the difference between Newtonian and non-Newtonian? No change in. Okay. So one suggestion, it would be subjected to the influence of temperature and pressure, right? So that is where basically you classify it Newtonian and non-Newtonian. So anyway, that we'll discuss further in the next slides to give a better clarity on it. But now, what is your expectation from the pen while writing it? Are you okay of having a thickness of the line of what more than what is you expected, or what is the line it's given? Not right. So you write it, you wanted a line with a specific thickness. So that is thickness, then without spreading up the surfaces. So you'll have proper smooth flow of the ink and while you are writing it. So that is a concept you also require. That is called the extrudability nature in its 3D printable concrete. And now once you print it over like one layer over the other layer, that is something deals with the deformability. So deformation is again subject to another cases where we'll be addressing this. And open time, something in concrete, again you talk about setting time and all, right? Similarly, you required a certain kind of a, again what we discussed about a fluid mechanics, again when we talk about Newtonian and non-Newtonian, you would have also heard about Bingham model, right? What is the main mechanism, or what is the principle behind the Bingham model? No idea. It is something about, again, when you apply there is a yield stress. What is the yield stress? So there will be yield stress in Newtonian fluids. Yes or no? So where the yield stress, it is constant. When you have the shear stress and shear strain, this is a constant, and there is little displaced at a constant rate. So whatever you obtain that value, we call it as a yield stress, right? So that is where from that point onwards, then shear stress against a shear strain, then there is a linear in which that is called plasticity. So proportion viscoplastic nature of the your fluid. So that concept is also important. Some like that properties are also important while you will be having of the 3D printing. So that extend to open time, then you have even bonding between layers, so settings time and strength development. So what I'm trying to discuss in today's session, because this is when you look at our theme of the GN course, is on characterization numerical modeling of the cementitious material. So in order to connect with the previous sessions to today's session and then the day after tomorrow's session, so this is something to deal with the metal properties itself, right? So now one such way is experimental investigation and another way is doing the characterization. But most of the things, so we'll be dealing with the material. So either it is a molecular structure level. So molecular structure level, one by means of the experimental investigation, you can understand the shape of the material, texture of the material, and then nature of the material. So all of these materials are important in terms of like to achieve the certain properties, so-called workability. But when you talk about 3D printing, it is something about achieving of the rheology. So you should know about the rheological properties in order to understand. So as I mentioned earlier, so rheology is not new for us. So we have been using it in the every day, right? So some simple everyday ideas what you deal with the rheology from the day morning you wake up and then you'll take up anything, either it is in the kitchen, either it is in your bathroom cabinet. So everywhere you witness of this rheology, right? So if you look at in the kitchen, there are surface cleaning liquids. Are you okay with the whatever you use surface cleaning liquid? You expected more watery, or it should be kind of creamy, or something. It should be kind of a solid. What do you expect from this surface cleaning liquids? So it is thick, right? So over the period, when you had diluted, you expected smooth flow. So that is also to deal with the, again, it is shear stress and shear rate. And when you talk about toothpaste, so what do you expect from the toothpaste? No, you have the tube. So in the tube, you have placed your product or the fluid, right? So when you apply pressure, when it comes out, is it okay if it comes in watery form? No, right? So you expected that smooth extrusion. So that is called extrusion. You expect it in the paste form, and then it's deposited over the brush. So over the period when you started using it, then it changes its form. So are you able to connect this to 3D printing? Placing it in a tube, then extruding it with in the paste form. So then the extrusion should be retention of its shape, because if it is spread across your brush, so while brushing it, so then that keep flowing out of your bed, right? So that is another kind of product. Then whatever you use it in garage, like oil, greases, same thing. This is all about dealing with the rheology. And you have in the pantry, so something about thick, thin, and then you will be having creamy kind of a thing. So that is in order to meet the consumer's need or demand or whatever of our requirement. So but now consumer here in the technology what we are adapting is 3D printing technologies to meet the demand of it. So this always what we expected from this, whatever we talk about cleaning liquid products, grease or salad dressings, or even if you talk about paints, or even if you talk about cement paste. So what is the expected rheological parameters involved in all these products? One is viscosity. So either low viscous or high viscous, something is what is required viscosity. Okay, after the viscosity, what you expected from this product? Maintaining the shape, that is called consistency. So you should have the consistency in of your mix. Then should serve the purposes. What? Okay, while serving the purposes, what kind of the property you technically dictate that? So having these properties would serve the purposes. Anyway, these are all to meet serving the purposes. But now when we are looking at the technical aspects or rheological aspects of it, So as rightly mentioned by viscosity is what you are looking at it. So if you want product like this, you have to maintain the viscosity. It should be low viscous or low high viscous. That is subjected to the negative implication or positive implication. Right. The second thing is having consistency, because when you have the shape, so you should have that consistency of the flow. So when you have consistency, it could meet the previous property called extrudability, where in the consistency you can have the continuous flow. If does not meet that consistency, so then you will not be having a proper flow or even the retention, right? So another important thing is texture. Are you okay if any texture it is appeared? So the another important property of this, the texture what you expect like in the from the toothbrush or toothpaste. So that is a kind of a texture you would be expecting from these rheological properties. So this is from the everyday's ideas. So basically adjusting the rheology to build the consumer needs or the demand or for the technology to control the rheology of the specific even technical reasons. So we often look for high viscosity to resist the flow and low forces forced by the gravity. So this is where we'll be looking at. And when you look up, talk about non-Newtonian viscosity, so this is varying with the upgrade of flow rate properties is very important. Again, now we start talking about non-Newtonian. What is non-Newtonian? Your concrete mixture is non-Newtonian or Newtonian? It is a non-Newtonian, right? So why don't you get your outcome of any common rheometer? Is it any rheometer would work for the concrete mixture or even the cement mortar? Rotation. Okay. So let's say you have bitumen, right? And you have bitumen and you have cement paste, cement mortar paste. So what is the difference between these two? So bitumen and cement mortar paste are fall under the same category of so-called non-Newtonian fluids. No, it's the first classification Newtonian or non-Newtonian. Then viscoelastic and viscoplastic we'll discuss at the later. Sure. What about petrol products? Newtonian. So that is where you should get bitumen falls under Newtonian fluids, whereas cement whereas in the cement mortar paste it is non-Newtonian fluids. So when you trying with the bitumen, so when you look at in shear rate versus shear stress, so it could start somewhere like this. But whereas your non-Newtonian fluid, when you fix with the Bingham model, will be having a yield stress. So where I had mentioned about its gamma and gamma dot, shear rate versus shear stress. So it will maintain the consistency at certain point, and there it will be displaced at a certain location. It's called yield stress. So that you don't notice it in case of the Newtonian fluids. But this is where you will be looking. You can look at non-Newtonian fluid. Then you will be having this is called eta P, representing about plastic viscosity, right? So these are the examples I had mentioned about the rheology, toothpaste. Then you have some kind of thixotropic solid paints. So these solids you will be converting, you mixing with the some of the either solvents or the water to make it of the required lubrication, or it is either to make it of more thicker, more thinner, or more creamy. So based on the requirements, then you convert this solid paints to the liquid or like the fluid one. So similarly, what example I had given about printing ink that needs to spread easily, right? So that is a major focus when squeezed onto the type of transfer of the surfaces. But once it is deposited or printed onto the surfaces, it in order to maintain its what called sharp edges you expected while writing it, and then they must not be spread by the action on surface tension or the gravity. So in order to have a control on this surface tension and the gravity, you are preparing a mix. If due to gravity, it starts spreading across, definitely you don't get your proper shape while printing of the concrete when you have concrete mixture, right? So always it is subject to gravitational force. So you don't expect your mix to change its shapes due to its gravitational forces. So there should be retention against the gravitational forces. And also if there is any forces developed from the surfaces, the bed surfaces, there should not be any reaction with the surface tension. So your mix should be retention in over the period while printing of it. So that is the just takeaway and fundamentals from the rheology which can be adapted for 3D printable concrete when you are preparing of your mixture. So this is most important. Changing with your fly ash, GGPS or any kind of a material or any aggregate, fine or coarse aggregate, that doesn't matter. That is over a period of it is the fundamentals of the concrete. But the most important thing is what important is we wanted to achieve this, maintain a sharp edges while printing it. So the takeaway and what is the best mechanism for us to always think about 3D concrete printing is your writing pen itself. You apply a shear stress, then over a period it will spread. You have the retention of the sharp edges and spread the action of should not spread the action on the surfaces or tension. So what is important? It will work in the sloping surfaces. Then how do you prepare your mixes? So again, when you discuss about the sloping surfaces, let's say if my axis is some in this way, if I'm printing it, again you should make sure that this will not spread in the gravitational forces. So whenever you play with the gravitational forces, so obviously even it would serve the purpose of printing in a sloping surfaces. That is what I had discussed in introduction part about the design freedoms. So it will give more design freedoms, but your mix is most important achieving the rheological properties. And those properties should always make sure that it won't spread any of these conditions. So maintaining the viscous enough to sit on the any surfaces, as you said, like sloping surfaces or flat surfaces, it should be viscous enough to sit on it, then it should not spread across anyway. And when you look at the flow, there is a two kinds of the flows. So one is the shear flow, another one is a extensional flow. So whereas in the shear flow, there is a adjacent particles are moving over the others, right? So that there will be even paste each other. So that is called the shear flow of any of the particles. But when you discuss about extensional flow, so adjacent particles are moving away from or towards each other. So this is a two kind of a phenomenon what you would be seeing it in the rheological properties of the cement paste or even in the concrete. So this is basic definition of the shear rate and shear stress. So by definition of the shear stress, so likewise you apply the force per unit area and where the amount of stress you apply it on the unit area, because that define it as the shear rate, sorry, shear stress. And shear rate is gradient of the velocity in the direction of right angle of the flow. That is called the shear rate. So where you can see that uh, which will be developing at a right angle. So that will be kind of a the gradient of the velocity would be giving it by means of the definition of shear rate. So this is range of shear rates for different types of materials. Then the very reason of giving this example is to identify suitable for your concrete mix. I'm talking about rheology. I'm talking about from the toothpaste to your printing ink to the 3D concrete printable concrete mixes. So again, you would see that when you the shear rate. So basically, this will be helping you to achieve the extrudability of a concrete. You have to control the shear rate. You cannot have the more high shear rate or low shear rate. There is some range of a shear rate is important to achieve the 3D printable properties. So any of the kind situation will be having sedimentation of fine powder in a liquid. So the shear rate will range of 10 to the power of minus 6 to 10 to the power of minus 3. But where we talk about something called extruders, so either it's a polymer, that would be the range, and you have lubricating, mixing and steering, that is where in the liquids manufacturing stages we expected the shear rate for our mixtures. So 10 to the power of 1 to the 10 to the power of 3 is required shear rate, and typical rheological graphs are in this fashion. So always your graph will be having a gamma dot is representing the shear rate, and then your shear stress is called the sigma, and that is where I was discussing about the Bingham model. So at a certain point, so we'll have this consistence from the shear stress against the shear rate, and further later on you'll be having a slope. The slope is called plastic viscosity, represented by the eta p, and likewise even over the period you will also address something about thixotropy and shear thickening or shear thinning, right? What is shear thinning? What is thixotropy? Anyway, both the cases with respect to the volume, but changes with respect to the what condition is important. So where it is something to address about the viscosity. So viscosity would be changing, it either increases or decreases, right? So whether it is just changing due to the shear rate or changing due to the shearing effect. Anybody knows the definition or understanding of the thixotropy or shear thinning? Yeah, by looking at these graphs, can you just decide something about this? No, that is, it's qualitative. But when you talk about something about quantitative, how the viscosity is decreases due to so and so, so will that affect, we call it as shear thinning. So in which cases we call it as thixotropy. So after reaching the yield stress, so in your mixture, is there any decreases in the viscosity? Have you noticed decreases in the viscosity or keep increasing the viscosity even after reaching of the yield stress value? Is it increases? The trend would be increases or decreases in the cement mortar mixture? Decrease. Constant yield stress if you apply. So when this decremental occurs, why is that decremental occurs? The question is about now why that decremental occurs. Now what do you talk about elastic, viscoelastic? So there is a pattern. So you can understand from this. But over a period now, if you want to define the shear thinning or the thixotropy, so that you need to again finally have to conclude it on what basis it is decreases. It decreases due to the shear stress. If it is decreasing due to the shear stress, will we call this as a shear thinning? Or if it is decreases due to the shear rate, will we call it as a thixotropy or the shear thinning? I think you would see this pattern, right? Something of this pattern. So thixotropy is decreasing the viscosity due to shearing effect, and whereas shear thinning is decreasing the viscosity due to the shear rate. There are two cases, so you should be able to distinguish shear thinning and shear thixotropic effect. And now, yeah, you just understand the fundamentals and background of the rheology, which is important for 3D printing technology. So overall, the 3D printing technology is lies on the basis of rheological properties. So what you would do after and before is something about concrete technology. But in order to understand a 3D printing technology, it is a rheology. And obviously, you do some tests, right? What all tests you would be performing it to understand or to determine the rheological properties. Slump is again about concrete technology. It's not about rheological properties. So as I mentioned about viscosity, so you set your viscosity to achieve the consistency, right? Or maintain the viscous nature by consistency, texture, and its shape. The fluid is flowing, but you want to maintain of these properties. One is viscosity, consistency, and the texture. What all test you perform? Anybody is attempted? You perform a vein shear. So what you understand from the vein shear? Do you apply shear rate over there in a vein shear? Yeah, what is that mechanism? Yeah. Any response from the online participants? Yeah, if you have anything to add, please add it. Yes. Overall working on 3D printing? No one. Yeah. So this side, I think these people are working on 3D printing. What is the mechanism involved in vein shear? You apply shear stress or torque or what is the mechanism? You apply a torque, right? So basically, when you are trying to play with a fluid, this is a vein, and vein will be rotating. And while rotating of this vein, and in order to control of your fluid, so you'll be having a boundaries. So that is how you have a mold, right? So this is a cylindrical mold. Then you have veins. So where you will be rotating of your veins by applying a torque. So when you apply a torque at a this specified area, so the cylindrical area is confined, right? So that is called A1. So this cylinder are also having this volumetric area. That is the area. So that yield stress, if you don't get any yield stress in by applying by using of the vein shear, so there you can understand whether it's a Newtonian or non-Newtonian. Where in the non-Newtonian cases, it's demands for the eye shear rate, eye shear stress. So in such cases, you are able to attain it, then this is kind of what you expected in the form of plastic viscosity. I had shown it in the previous diagram called in the Bingham model, right? If it is not achieving it, that is not the method you are supposed to perform it, but that is indirectly indicate that. And why do you perform a slump on this or a flow? Yes, it's nothing to do with your pumpability. Actually, in order to perform up this shear test, vein shear, so you are making sure that your mix is in Newtonian or non-Newtonian. So the pumpability is in a different parameters, right? If it is very flowable mixer, then you cannot even get your yield stress. So even if it is a very solid, your yield stress will be in a higher side. So but now in order to achieve of your extrudability, you should maintain of that yield stress value. What is the yield stress value ranges for 3D concrete printable mixtures? What is the value range? 3 to 4.5 kPa. Any other values? Same. So this is anyway, basically you try to understand, and in order to achieve that, there you maintain of this, like whatever yield stress is there, this you have to define, but this is subjected to the material properties. Again, under the category of non-Newtonian fluids. So this is what you want to achieve it, like it may be vary from 1.8 to 2.7 kPa or even 3.5 to, it is subjected to the kind of a material we would be using it. So this is kind of a yield stress you are trying to achieve it by using of the vein shear test is one such kind of the method, but now you have the rheometers. But overall process, what you are trying to understand over here is you are performing a viscometry test. So what is the definition of the viscometry? It is a method, right? So what is the viscometry? Viscometry is science of measurement of the velocity. So what you are trying to determine in this test, science of measurement of the velocity, uh, sorry, viscosity. It's not about velocity. It's a viscosity, measurement of the viscosity. Again, viscosity we discussed extensively on various properties of the viscosity, right? Same thing. So you convert the applied force F to a shear stress, that is sigma. So where you have shown it in the graph uh, of sigma, then convert the velocity V to the shear rate. It is not about our elastic deformation here. So that is where we define it as a shear rate, or we can also say it as a strain rate. Some cases even we name this as a strain rate, right? It is subjected to the type of material you would be using it. Again, basically the classification from the Newtonian or non-Newtonian. So you will have flow in a straight tube. This is for a bitumen. I think if you have performed any test on the rheometer for a bitumen, so you adapt this mechanism, flow in a straight tube where the shear stress varies linearly from the zero at the center. So that we don't notice in case of the non-Newtonian fluids, right? Center to PA by 2L at the wall. You'll be applying this formula to find it out the respective shear stress, and then flow also you'll be measuring it, right? That is called the velocity, and velocity you are converting into the shear rate. Now another case is flow in the parallel plates of the viscometer where the shear rate varies linearly from the zero at the center, A omega, then you have a H at the edge of the plates. And another case is what you talk about vane shear is the last method, flow in a wide gap concentric cylinder. So where the shear stress falls off as the inverse square of the distance of where we'll be having a shear rate from the center of rotation. So this is a formula you apply it, torque over by 2h of by r square. So r square, sorry, this is gamma, I think. This is something about area where we'll be defining it and then applying the radius. R is the radius here, which is taken in order to measure it. So what are important while performing the test? Either you use a rheometer, either you use a vane shear test, but you should make sure certain important, you should notice some of the important things to make sure that whatever kind of experiments you would conduct it in order to measure the viscosity by means of, or we go for viscometry. So you should do the calibration. How do you perform the calibration for a rheometer? Yes, how do you perform a calibration? Have you done calibration for rheometer? How do you calibrate the rheometer? Yeah. So they give the known fluid, any kind of a setup, because that is kind of like a standard sample we'd be using it, so that we don't need to have much of the variations in any of the cases. Same thing, we also apply it in many other mechanisms. So use a known fluids to check that whether it gives the pattern what the kind of a known fluid should be behave in it in the way. So once you assure that, then you would take up your samples to test it. First of all, you should make sure the calibration. So once you make sure the calibration, there could be something called artifacts. So there should be error. So you have to rectify error. Like in the known fluid, if there is anything, although the standard fluid is known, but there could be some error of your system. So that's called artifacts. Any zero or any errors, you should mitigate those errors before you perform the rheometer test time. Then there is something called wall effect. I had shown it in the previous slide, right? There is a constant cylindrical, basically, when you use it for Newtonian fluid, you will be having tube-like structures in the rheometer. But whereas when you deal with the non-Newtonian one, you will be having cone-like structure. So same effect of Venture, right? So we'll have cone. So that is where you place your fluid. So then you'll be having a side wall effect. So that side wall effect, you should always make sure whether that gives any error on your test. And further, you should make sure like some of the tests where you would be like when we had a water and all, so there is chances of evaporation. So you should make sure that there is any no evaporation of your samples. And you should make sure there should not be any sedimentation. It is all subjective to your kind of a material, but most common practices, what is important things to be taken care while performing this viscometry, or while performing it on the viscometer. Then you should also make sure there won't be any chemical attack from the other foreign substance. There should not be any mechanical damages to your sample. They should be very carefully done of your sampling. And there again, sometime you, when you apply this force, right? So that is also important, whether you apply high speed or low speed. So that consistency should be maintained, and the standard should be adapted while testing of your sample. And there should not be any suspended particles. Also, like you prepared your samples, made it as a homogeneous mixture. By the time when you place it in a viscometer, either in a cup or plate method, so by the time the kind of particles are suspended. So in such cases, those results would be not accurate when compared to the what you expected from your prepared sample. So the sampling method and making sure of there is no suspension of the particles of your prepared sample when you making it little bit more fluid in nature. So such cases there is aggregation or suspension of the solid particles, right? So these are maybe different types of the test have been adapted or from the years. And further, if you look at kind of models are available for performing of this Rio property, one you have it from the Brookfield, and then you have from the again Rheometric RM180 R265. There are many about Rheologica, Viscocheck, and these are different models are available in the market in order to perform this uh, viscometry. For a concrete, the most suitable equation is Bingham equation. So where you have this equation, adapting of this equation, you would be trying to perform the test and relating, developing your graphs with respect to this equation. And even by defining the sigma y is a yield stress, the point at which you will be getting about the yield stress. From the point of yield stress, it start behaving of shear stress against the shear rate in a linear form. And finally, you would be getting the plastic viscosity. So this at a reasonable range, there should be proper share rates and share stresses, which seems to be good with the linear equations or linear function of the share rate. And whichever is displaced upwards by constant value is called the yield stress. So this is all about fundamentals and the basic science required for going with a 3D printing technology as far as the this GN program team is concerned. So now further going with the some case studies of the what work has been done. Yeah, that is something deal with the polymers, not with the cement 3D concrete printing. So again, polymer, when you talk about polymer, then it is basically you should be very clear with the kind of a fluid. So the whatever we talk about a Newtonian, it is subject to the changes in temperature and pressure, so it changes its property. Otherwise, there is a linear constant nature of the value. But now, how do you think? Like how much of the temperature it would take? You don't have any devices to influence the temperature on the mixture, right? So where this temperature come from while printing it? 3D concrete printer does not generate any of the heat or anything while printing it, right? So where do you expect this temperature? It is only in case of polymers, not in case of the concrete. Yeah, this even additive manufacturing, your polymer printing, metal 3D printing, these are all temperature based. So they give a heat, and while even solidify also, they give a they heating it up to solidify and then form the texture. Right. Once you print it also, same thing about our geopolymer. Right. So while geopolymer, even after set also, you won't achieve the required properties. Either it could be strength. So in order to achieve the required properties, further you going for oven curing or nothing but the heat curing. So some influence of the temperature is required in such kind of the uh, fluids. So that is most common in polymers, polymer printing or plastic printing. So you need to so you have a roll. So while to extrude, definitely it required heat too. spread across while passing through the operand and the nozzle. Any questions on rheology? Yeah. So what so far we discussed is still we are not even printed anything. We talk about only what is required for pumping and extruding and retain the properties. So over the period, then what is required for our conventional concrete? Then we have variety of concrete, no? It is all something about concrete. So we have fast setting. So we have rapid curing agents are there. So but those admixtures should not influences on these rheological properties. So either you want to do it as external or internal, that is subject to the your. But now most common practices we have accelerated curing method, right? So that is a practice we have can implement even 3D concrete printing. So accelerated curing are more than sufficient for a certain period of time. You know that exit curing, then over the period it will get strengthened and then achieve the required properties. Yes. Any questions? Compressive strength and setting time. Mm. Mm. Compressive strength is individual metal properties. So let's say if you define it for M40, so up to M40 it is able to resist the load. Either it's in the first layer or the last layer. Mm. No, that is something to deal with your either once you extrude it, it is in a elastic nature or the plastic nature. So when it's converting what we talk about nucleation, right? Elastic to plastic, plastic to solid, right? So when it is achieve the solids, it is tendency to take the more loads. But when it's in a fresh state, it is designed in such a way that it should be able to resist the immediate layers. And by the time when it is reached to the top layer, this is already set enough. So this set enough and it got hardened enough. So when you look at the plastic conditions of the first layer printed and the last layer printed on the top, so there is a significant changes in it is kind of a setting behavior. So it got hardened, then it is already ready to take the load from other layers. Mm, mm, yeah. Again, if you want measure that in the rheology, then you have creep. So over the rate for your setting, then there is a creep. So how much of it will be deformed. So deformation is also allowed at a certain level. So when this load is taken, then completely it is compressed or it is like becomes shrunken. So in such case, definitely it is not taking a load. But you are preparing your mix design in order to take those loads in a fresh state as well as in the hardened state. So while printing, it is at a fresh state and that should resist. When it's getting setting hardened, then you have to prepare your mix in such a way that it's able to resist it. Basically, it forms the interlayer bonding. So if you are sharp edges, so this chances of binding with the next layer is very less as compared to when you have flat surfaces. So, but at the same time, you don't want to lose this retention. So safe retention is also important. Becoming flat, then you will not achieve of your design model. So it get deformed. So when it's get deformed, there is chances of collapse. So that is again more to deal with your behavior of the material. So once post extrusion, it is again about our mechanics, engineering mechanics, what we deal with. So again, metal properties, it is rheological properties up to the deformation. So once it's set, then why this material changes? So then you have to apply the mechanics. That is called open time, right? Print and then finally build it for cavity. Yeah, achieve the properties. That is where it is something different than the normal concrete. So just to go through the case study, based on understanding of this. So this is done by the team, like what they have done it by using of construction waste. So generating the waste, then process. Finally, you get recycled fines and coarse aggregate. So here, so yeah, you have done kind of a modeling or a iteration process for ordinary Portland cement, fly ash, GGPS. But now the main crux of this case study is using of recycled fines and investigating of those properties, including physical properties for particle size analysis, and respectively you have the properties of the binders and SEMs at various conditions. And this is a characterization, but I just trying to mention a method and then come some of the insights from this. But the more detail about these mechanism, the characterization will be discussed on the last day of the session on material characterization. So this is scanning electronic microscopic images would give you the information about the nature of the material or the kind of either it's a regular shapes or irregular shapes or spherical shapes. So those are important not to achieve your viscosity of the material, so that the lubrication effect what you can notice it, so that that will be allowing you to proper flow without any of the segregation, right? So likewise this will be allowing you to understand the morphology of the raw material or even for the mixtures by adapting you of this FECM. And this is where we'll be giving a elementary composition. So again, one of the characterization tests what we would be performing it to understand the oxide compositions are present in individual raw materials like glass, GGBS, and those compositions. Let's say if you talk about some of the limestone, raw material of the limestone, right? So some of the when you look at the geographical deposition of the limestone, somewhere it is rich in magnesium, magnesium oxide. But whereas in the cement manufacturing, we limit the magnesium oxide up to 6%. So in such cases, you alter the overall manufacturing process in order to produce the clinkers, right? The similar concept would be applicable here in order to strengthen to meet your requirements of the rheological properties or over a period of achieving the fresh properties and hardened properties of the concrete. So these studies would be helping you to understand and then analyze it so that you can try to achieve the optimized mix going through the different proportions of it. So that is the kind of insights what you would get it from the EDS, and also you would be getting it from the XRD analysis. And XRF, the kind of a test what I had mentioned about different oxide compositions. So this you can understand from the again another demonstration session on the XRF. So this is schematic what we adapted while printing it. So again you prepare your mixture based on the rheological properties. So then you have pumping systems. So that is where I had mentioned one such parameter is pumpability. Then you have the hopper or nozzle where it is basically helping you for the extrusion. So extrusion nature. And finally, this is 3D concrete printer, robotic type of 3D printer. In the afternoon, we would be giving you demonstration on the printing of 3D concrete printer. This is hopper capacity of 20 kg. So the significant findings from this, so yeah, this is just on material properties, but what I would like to give more understanding on the rheological properties and their behavior 3D printing. So again, you use the fine and coarse aggregates as the replacement of recycled construction waste as a recycled fine aggregate and coarse aggregate. Definitely, this is as per the standard. Just you would test it and make sure that it is fall within the limits as per the standards to use it as the fine and coarse aggregates. So similarly, this is for a coarse aggregate and heat of hydration. That is where it's again connected from the very first day session. How do you test it for the ordinary Portland cement and with their other percentage of replacement with the recycled fines, whether it changes in any of its behavior of the heat of hydrations. So when we are, yeah, whether we want low heat of hydration or high heat of hydrations, accordingly you can set this concrete. Similarly, you test this flow. So I already mentioned about the reason of the purpose of flow. So whereas in normal concrete it is just about the work cavity, but here it is not just about the work cavity. In addition to the work cavity, to achieve the rheological properties, so this is again done by our team. So where you can understand from this images, if you have proper flow and required yield stress and proper again it is about the viscosity, consistency, and texture. So that difference you could see it from this to the concrete one. So as it is a extruding, so and it is a continuous, it is meeting its viscous properties. But over a period, once it is consistency is important. The consistency you could understand when it goes to the one layer to the other layer. If that is not consistency, then the bottom layer will be deformed and top layer will be maintaining that sharp, I mean, whatever the shape retention. So that is where we talk about the consistency. And last about texture. So now it looks like the very of a fluid in nature. It should supposed to give a smooth texture. If there is any cramps or any kind of small pores are existing, then the texture still need to be improved. So that is where you can understand from the rheological properties. This is mud-based 3D printing. The previous one is a concrete. Just for your understanding the flowability and this. Yeah, I think I already mentioned about the different research scholars are working on different concepts of it. Yes, so again, it comes from the physical properties. To achieve the viscosity, again, you have to set your physical properties and the chemical properties. So the ultimate goal is to achieving the rheological properties. L- Yeah, there is a, I mean, ranges of these because now you would have heard about 3D concrete printing does not have the coarse aggregate, right? So unlike where we use 20 size of the aggregate, so there are limitations on the using of size of the aggregates. So which is the best suited one is the cement mortar mixture. Now, if you want to further improve it, then you do a trial and error method, again achieving the rheological properties. So whereas when you go for the larger size of the particles, you require higher shear rate. So when it is required higher shear rate, it is not just about your mixture. So it is also important of your whole system, the pumping system, the motor system, what you would be using it, and then the way the force what you will be applying it. So when you apply the force and velocity plays an important role. So when you are able to control the force and velocity with your mixtures, then you can go with any size of the aggregates. But most importantly, that is where you face a challenges, right? So in order to improve that, I mean, in order to improve or in order to go with the better size or larger sizes, always you have to achieve the rheological properties. You don't need to go for a printing at a first instant. You do a trial with the rheological properties. So once you would be able to achieve that viscosity, consistency, and then the texture, so then go and do a trial with the printing. Before that, it's not necessary go for a printing. So this is about the uh, slump. Once you're done with the slump, then you testing it for the rheology, something connecting with the rheological behavior. So here you could understand that the yield stress varies, and then as subsequently you could notice that the viscosity decreases either with the with respect to the shear rate increases or viscosity decreases with respect to the sharing effect. There are two cases. So as I already mentioned about the shear thinning and the thixotropy. So thixotropy is where you can understand with respect to the sharing effect on the mixtures and then further classifications or the behavior of the material. This is representing the percentage of replacement of the recycled fines against the ordinary Portland cement and their behavior with respect to the rheological properties. And similarly, if we have open time and then yield stress, So this is something further. Once you executed the executable properties, then you have printability and buildability of 3DCP ink. Again, the the very first test what we performed is the yield stress and then the open time. So where you could notice that for your question for the layer over the layer, once it's not able to resist the load, so you could notice the buckling, that is called deformation of the materials, and due to the changes in its value of the yield stress. So you have again deformations. Finally, best achieved buildability is up to 540 mm. So this is printability trials where you can notice for the mixtures. So here also you can relate with the rheological properties how it is connected. And then you have control mix and optimized mix with the normal concrete and then the recycled construction waste based concrete mixture with a structural recovery rate percentage has been compared with these two mixtures. So yeah, here you could understand the texture, so which is not enhanced. So again, there are kind of admixtures or essentials to improve the texture. Again, you add that, try with the rheological properties. Once you achieve the rheological property and go for the printing. So this is further investigation has been carried out on understanding the basically to optimize the stability behavior of 3D printed structures. So using this framework, kind of a numerical analysis to understand the behavior of 3D printable mixes using finite element method. Oh, you have 3D model here. As I mentioned, it's used Rhinoceros 8. Then you have in a grasshopper, you develop the required inputs. You can give it and connect it with assigning up those respective properties in grasshopper. And this finally you can perform the analysis in a abacus. So going with the static implicity analysis in this case, but there are other ways of even trying with the vibration control when we are dealing with dynamic analysis. So this is typical framework where you can perform the test and you could understand the printing behavior so that it will be helping you to validate your 3D printed concrete and the structures to go for or to scale it up for the large scale. So this are like the buildability assessment, and finally you know that this is in a conventional way you would be investigating to understand the mechanical properties, which obviously you would be doing it for any type of a concrete to investigating on the compressive strength, and then also you comparing those results with a non-destructive analysis, so-called UPV. And again, like we have done both the methods. One is for cubes and another one is for extracting the 3D printed structures, and we tested on both the methods. But I think results presented over here is with respect to the cube strength, if I am not wrong, correct, Nitya? So this is flexural strength. Again, you need for interlayer bonding. Your concrete should also achieve the flexural strength. Then this is thermal properties where you look at other functional properties of the concrete. We also performed a life cycle assessment of this product because since anyway, this is not very relevant to this theme of the GAN program, but just to make it contribution to the sustainability, what is essential, we perform this sustainability assessment. So this is these are the concluding remarks on the technology of coming up with the innovative construction materials and emerging technologies will reduce environmental impact and then improve all of these properties. These are some references. Thank you. Is my phone? Yeah, if you have questions, so I'd be happy to take up the questions and then answer. So, is the time now? No, late. So the strength, obviously, cube will be giving a better strength as compared to the printed one. So the metal properties, when you are applying the compressive force, still that is able to withstand with the force up to the whatever we designed for M40 MPa. So the problem with here, the compressive is okay, but when you're applying the force and perpendicular and parallel to the layer, so it is subjected to the interlayer bonding. So that test is still under the trials. So we have been investigating on that and trying to improve those properties, because it is always subjected to when you apply the load, some kind of a texture appearance, what you have seen, some kind of crumbs, right? So they will form the weaker zones. So obviously that never expect that achieve the better strength than the prepared cubes. Mm, mm.
Aspects also. It will help in durability also.
Durability aspects
So,
of,
like permeability, water absorptions. In that also, it will be good enough.
I mean, texture is obviously it's good enough for the durability aspects, particularly we talk about permeability. So but these whatever crumbs you have noticed is on surfaces when you printed a layer. So I think if you talk about even if it is a one, not even 1/4 of layer. So but still there is a prevention of any such kind of the extreme environments. But when you talk about durability, how the material is getting deteriorated when it is exposed to the such kind of the environment, it is not about it, it will not compromises on the durability, because there are still number of layers are formed to prevent from those exposed extreme environments. But
Even
having a better texture, it will definitely enhance the durability properties. So this we trying with the just construction waste. Still there is things to be improved in terms of achieving of even structural properties or engineering properties of it.
sorry, it can be used in a repair and rehabilitation purpose also. This type of technology we can achieve to use.
Obviously, you can use it. So there is no limitations on the applications. Wherever you find it suitable, it can be used for repair and rehabilitation.
Excuse me, sir.
Excuse me, sir.
Which one?
Sir,
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 Yeah,
is
I
it
think
audible?
is it out?
just tell to wait. So yeah, ma'am, just wait for a minute. I'll take up one more question here and I'll come back to online
Okay.
participants.
Okay.
Yeah. Yeah, as you rightly asked the questions about the fibers, but
Yeah.
there are different types of fibers. So even there are the cases like where you can go with nano based. So again, you never compromises on rheological properties. Whatever you would use it, you have to use or prepare your fibers in such a way that it is suitable to achieve the proper viscosity, consistency, and the texture.
So if we are increasing the dosage of fiber, then definitely it will affect the workability, right? So
Mm.
accordingly, we have to adjust the SP or admixtures.
Mm.
So how, like up to what limit the SP is used, maximum
So maximum, yeah, with the 0.5%
with the
of.
fibers or like
No,
with
we are not used any fibers in
fiber?
this.
Okay,
This
without.
is basically dealing with the construction waste,
Okay.
not we can further extend it for the fibers. So SP 0.5% is used to achieve for these mixtures. So that is where you could see some of this texture. So there is further investigation is essential in order to address those issues. But when you use the fiber, if you talk about the concept show it, it is like again your size of the fibers, again type of the fibers. So whether you want, you can definitely when you go with a steel fiber, it is all about your pumping system, the diameter of the hose pipe, and then kind of the a force you apply it on the pipe, because it is not just pushing of your mixture. It is about like the limitations or challenges of using of the coarse aggregate is pumpability. In order to maintain the viscosity and then allowing the pumpability is again challenging, right? To assure that, you need to always make sure that this is homogeneous mixture, and then what I had mentioned about sedimentation, those things should not occur it, because by the time it reaches to the nozzle, it will not extrude itself. There you notice the challenges. Then the further thing will go with printability and all, but now you address focus on extrudability. So, but there is a scope. There are already studies which have been done on introducing of the fibers and all. But You have to fine tune or optimize size of the fibers when you are trying to use it in 3D printable concrete, because you use aggregate size of 6 mm. Let's say if you're not even a coarse aggregate, you use a fine aggregate up to the 2 mm. So when your case the fibers is the longer than your finer aggregate, definitely it brings kind of a choke, right? So that choke will be not allowing you to even extrude or even to flow. The flow is more important. So when it is building the mechanism of choking, so that will stop or it will lead to the segregation. So that should not occur in your flow of the flow concrete mixture. Yes, yeah, now I'll take up questions, couple of questions from the online, and then I'll come back to you. Yeah, participants, please go ahead if you have questions, online participants.
Sir,
Sir,
about the
about the
contact
contact
layers,
layers,
those will be
those
the
will
weak
be the
points
weak
of
points
the
of the
structures
structures
created by this
created by
3D
this
printed.
3D printed.
Yes.
So
So
how
how
can
can
we deal
we
with
deal
those
with those
weaker
weaker
point?
point?
We are trying to enhance this interlayer bonding. So that is where I think we addressed with we try to measure the thickness of our printing layer and height of the layer. Is there any deformation of the individual layers and layer to the other layer? If what is the contact area built between the two layers, so that is again we tested with the bond strength, and that bond strength is indicating the stronger or the weaker section of the this interlayer bonding.
So the
I hope
stress
Stress
concentration will be
concentration will be
happening there.
happening there.
yeah. Yes, stress concentration is happening over there. That is where you always deal your material in the fresh state by means of the rheological properties. So you try to understand the behavior. That is where you need to understand shear thickening and shear thinning effect of the materials.
Okay, sir.
Okay, sir.
Any other questions?
Sir,
Yeah, I'll just complete online participants and then I'll come back to you. Yeah, please. Any other participants or online, if you have any questions, yeah, please, you can.
Uh, Sir, as we seen, it is applied for a small scale.
Hmm.
Uh, do we come across any problems during this application in the large scale?
Yeah, large scale is what we addressed in the deformations.
Like,
So printing layer heights. So we printed up to 540 mm, right?
yeah,
So when you're going to scale it up, so we need to print it up even the larger scale. So that is where we need to address. So even if it is continuous, even after 540 mm or whatever height we build it, so there is no issues with this mixture. But there are a lot of cases where already built the large scale structures using 3D printing technologies.
Sir, regarding the models which are printed with the 3D models, no,
Mhm.
is there any standard testing procedure for the printed models, or only the mixture has to be tested with casting the cubes?
So standard testing procedure, again, it is a trial and error method. Like as I mentioned about yield stress, rheological properties. Obviously, for those tests, there are standards are available. There are ASTM standards and find it out viscosity properties. But when it comes to the our mechanical properties or the conventional test, what we would be doing it, there are no existing standards with respect to the 3D printable concrete. It goes with the trial and error method, and also like the past whatever the literatures are available is one such a way. I would prefer to go by trial and error method rather than any other, because it vary from materials to material and the kind of a mechanism we adapted to print and then the kind of a 3D printer. So it's always better to understand the behavior of the concrete by trial and error method, or use some kind of a simulation techniques to understand the behavior. Likewise, as I mean, other expert, international expert is talking about numerical modeling, no, like anything about a molecular level structure. So we can do the modeling and try to understand behavior of the materials. either in terms of the hydration or in terms of the exposed to extreme environment. So that is all based on the inputs what we give it with respect to the material properties. But whereas for the large scale, we have to do it on our own structural engineering mechanism. We have it to test the properties. Yes. I mean, properties.
Properties like a yield stress, exotropics, all those
Mm,
things we
mm.
can apply to geopolymers.
The challenges in geopolymer is like achieving the required strength.
Yes, sir.
So this rheological property is not, I mean, dictating over the or not helping you way to achieve the strength properties. It is helping you to achieve pumpability and flowable properties of the concrete. So when geopolymer concrete, like if you have kind of a mechanism to improve the strength, because what I understand for a conventional way of doing a geopolymer concrete with a air curing or even a water curing, you could not achieve the required strength.
If it is a pass means we can do.
Yeah, but again, a couple of challenges what you would face it. There are cases already they have done it with geopolymer concrete, but you should always make sure kind of a alkali activators and kind of a setting. So if while pumping it gets set hard, so then you have to pay a lot on of your pumping systems and the 3D printer.
If you go with the lower molarities, we can achieve.
I mean, there is no problem. You can try, but this is just my suggestion. You make sure that if you are able to try with that, you can try. But there are cases already geopolymer concrete. There are and couple of structures are already used by adapting up the 3D printing.
Sir, in one of the slides, you have mentioned about the different kinds of binder materials like GGBS, OPS,
Mm.
and fly ash, that particle size gradation. What is your view? How it is affecting the printing parameters in the while printing?
A printing parameter, if you're keeping aside of the printing parameter, irrespective of it, this particle size gradation is important to have better particle packing.
Okay.
So if create more whites, definitely it would compromise on its properties. Even one way because as I said that fluid will be having gas form. That gas form will be leads to the compromise and strength. So whatever whites created due to ill-graded materials. So it is not well graded, like proper gradation is not there. There won't be proper packing of the materials. So once you compromises on packing method, it compromises on its density, and over a period, it will also not contribute to the strength.
So
So
this you are mentioning regarding the fine aggregate or even for the cementitious materials also?
even for cementitious materials as well.
Even.
So I think you would also noticed in when you use silica fume, right? A lower fraction and then higher fraction. You could understand what all the changes you would notice in concrete. Uh, because always it will have effect. One is like, yeah, in cementitious material, what we talk about finer and coarser, and there is a range. As the finer the particle, it will be having larger surface area. As a larger surface area, it is also demands a more water content. So when you talk about more water content, to reduce the water content, you will use more of superplasticizer. So once you use more of superplasticizer, then it will delay of the setting time. So these are all kind of a consequences. So that is a concrete technology, either in the case of 3D printing or in case of any other applications. So very reason of going with the well graded is you will be having proper combination of the size of the aggregates or size of the particles. So that will be allowing you when the larger the size and smaller size and various combinations going with the proper packing. So that packing will be allowing you for better strengthening aspects of it, or even better workability also.
What about the reinforcement? That also have beams, some of them casting beams, columns, like printed beams and columns. Then how about the testing and all? Like we can use the similar testing which we use for normal concrete.
Yeah, it's same. I mean, as long as structural behavior is concerned, the same, because basically what we are trying to investigate is engineering properties. So it doesn't matter which shape of we are using it. For example, I'll give you like steel structure, or we have the pre-engineered structures building, right? There's changes in its structural sections. So either we go with I sections or we go with the C sections. So, but no, it doesn't matter in terms of the testing of its flexural behavior, right? Still, we follow adapt the same guidelines as per the standard. So here also you can adapt the same set of standards. Just you compare with that. How does it behave with the control specimens of the concrete where typically tested for normal concrete and this one.
Sir, how about the thickness? Like, what size of beam will be printed? Like, we can, if we are using for 3D printing, what will be the size of
That
the
is
beam?
same because there is no standard exist as for as like for 3D concrete printable structures. We adapt the same available existing standards what is followed for other cases. So if you talk about RC structures, so what is the size of the beam we prepare for a testing? We can go with the same size of the specimens for testing of even 3D printable beams and columns. Because that we done like that is evolution, right? When we have masonry beams and columns as a bond beam, so we had set up standards. Now we have in then further development we went to the RC. Now we are going to the 3D printable. Okay, so I think I've answered most of the questions reasonably in a good manner and hope you got some insights from the sessions. Thank you so much and yeah.